All right, I think we're good to go. Everyone's got pizza, everybody's got drinks and top-ups. I'll just start off with a little quick introduction about myself because I forgot to include a slide like that. Adam, you reminded me to do so. My name is Tristan. I'm a software engineer. I've been working with Ruby for quite a long time. I remember when Rails first came out and thinking, this isn't going to catch on. So I have been playing around with it for quite a while. These days, I mostly work with JavaScript, C++, and Ruby. So I still get to get my hands dirty. And the talk I want to do tonight is on something that came up in a conversation with a coworker. Late last year, we were talking about Sorbet, and we were wondering, how does it work? You know, this whole annotation thing is a bit interesting. So that's what I'm going to go into tonight. And the whole idea is really to take something that looks quite magical in Ruby, as is often the way, and to peel back some of the layers and see how things work.
All of this.
Oh, sorry.
Okay.
So the rough outline for tonight is I'll start off by introducing type checking, what that means. We'll talk a bit about Sorbet because even though it's quite well known now, you may not have actually spent some time looking at it. Next, we'll look at how Sorbet could actually work. So we'll look at the syntax and we'll see how this annotation style syntax is possible. And then we'll actually go and build something to do this for us. Part two is really going a little bit deeper because as part of this, we're using metaprogramming, which is a fairly advanced feature in Ruby. And we'll see how we can really take advantage of that to make a powerful type checker. So first of all, what is Sorbet? Sorbet is a library for type checking in Ruby. The area or the aspect of Sorbet we're going to look at tonight is runtime type checking. So that's while your program is running, how can you check the types of variables and arguments being passed around? The other thing we can check with Sorbet is return values. So in this little example that I've pulled from the Sorbet website, we can see we've got a class called main and it has a single method inside it. And above that method is the Sorbet type signature. We can see from this that it accepts one parameter called name and it returns an integer. And if we read through the code, we can really argue that it does that. But once you start looking at more advanced methods or you start chaining things together, that's when type checking becomes really critical. Now, what I wanted to do with these two slides is just illustrate how some of the magic of this comes about. Because when you first read this doesn't really look like Ruby, this little line of code above a method declaration. So let's start to break it out a little bit. First of all, we remember that the curly braces are really just shorthand for a block. And then we realize inside that these params and returns calls, these are really just method calls. So what we're doing is we're calling a method called params, and then it returns something else that we call a method on. That method is called returns. And then we put all of this before our method. But how does that actually turn into type checking? Well, that's what we're going to dig into today, looking at how this annotation style syntax works. How can we drop that thing in there above a method in Ruby and actually have it do things? Now, if you do want to follow along or check this out later, there's a repo on GitHub, which has what I'd call workbooks, broken into two parts. One is corresponds to the first half of the talk, and then the other one corresponds to the second half. Now, the example that we're going to use for this talk is this repeater example. So it's a little class called repeater, and it has one method called repeat. And all it does is it takes a string that we pass in and a number of times to repeat it and a separator. So it's really just a glorified join function. And we're going to look at what happens when we add types to it. anytime you see a little gray box like this, that's just example output from one of these programs that we're looking at. So we're going to build this up step by step. And where we're starting is we're just going to say, how can I actually look at the arguments that have been passed into my method? Now, the easy way to do this with the repeater method would just be to add these two lines in bold here. So we've got a puts before, which tells us what has been passed in, and we've got a puts after to tell us what was returned. And you can see in the output here, pretty much what we'd expect: before, after, and then the actual result, because we've got a puts on the final line here. Now, things are getting a bit more abstract. And the reason we're doing this and going down to the level of using lambda literals is I want to show you how we can start to tease these parts into the different steps that we want to work with. So we've still got those puts lines before and after. But what we've done is we've changed the parameters going into the repeat method. So we're using these rest parameters now, and I'll talk more about them later. Then we've taken our original body and we wrapped it up in the lambda, and then we actually call that. So that's what we see on the fn.call line. We're actually just passing in the arguments that we received and passing them into the lambda literal. Now, if we go back and forth between these two slides, we can start to see something happening here. So we've gone back to what we had before, where we have our repeat method, and it looks exactly like it did in the very first example. And we've actually taken the puts lines, puts before and puts after, and we've moved them outside of the method. So anyone who's been doing programming for a long time and maybe has come from the Java ecosystem might recognize this as looking a bit like aspect-oriented programming. That's what it used to be called. But what this tells us is, or it gives us a clue about, is what we have to build to make this work. So one of the things that often surprises people about Ruby is when a class is actually being loaded for the very first time, this isn't just declarative boilerplate that only the compiler knows how to work with, or only the interpreter knows how to work with. What's actually happening is your code is just being run from top to bottom. So you can call methods at any point in a class, as long as those methods exist in scope somewhere. So we've got two methods we want to call, before and after, and they have to come from somewhere. So that's why we have this line at the top, extend hooks. Because what that does is it gives us a place to bring these methods in from. And this is, if we go back to the very first Sorbet example, this is actually what Sorbet is doing. You can see at the top of the main class that it extends from this tsig module. And that's actually where sig and params and returns are all coming from. So that's starting to peel back the layers of the magic here. We're realizing that we're just trying to find some methods to call. We have to bring them from somewhere, so it's probably going to be a module. And it starts to inform the design of our solution here. So this tells us we need to build this hooks module, and we need to provide two methods, before and after, and to somehow wrap our repeat method so that it calls those. So this is the basic structure of the hooks module. We've got our two methods, before and after. They actually don't do much. They just store the lambda literal that's passed into them. Then where things get really crazy is this method added method at the end here. So this is the first example of how we're going to use metaprogramming in Ruby. So what's cool about method added is whenever a method is added to a class, this gets called. So you could read through repeater X here, and once we get down to def repeat, that's actually going to cause method added to be called. It's basically a little way for us to hook in and say, just tell me when this happens so that I can do something with it. Now, I'm not going to go into too much detail about how we use method added, because there's a little bit of logic here to ensure we don't end up in infinite loops, some bookkeeping to make sure that we can reuse our annotations once we're done with them. And I'm going to skip down halfway through this method and call your attention to two areas. One is the first call to instance method in the middle. So what this is actually doing is saying, I need a reference that I can work with that points to this method that's been added to the class. And I just want to store that so that I can reuse it later. And then the next thing we use is define method. And what define method actually does is it allows us to programmatically add methods to a class. So we call define method, we pass in the name of the method that's just been added. And this effectively overwrites it, puts our new one in place. And then we've got lines to call the before and after methods that we've defined, or the before and after hooks. And then the bind self call line is the one that actually goes and calls the original method there. So there's quite a bit of indirection going on, but we can sort of see how it pieces together and does what we want it to do. So revisiting our repeater example, we can understand a bit better now what's happening when each of these lines gets executed. So from the beginning of the class, we extend the hooks module. So we're basically bringing in before and after as methods. And what happens is we call before, we pass in this lambda literal, that gets stored away for later. We call after, we store that lambda literal and we can use that later. And then finally, we define our method. And at this point, method added gets called. And because we stored those lambda literals, we can actually go and reference them from this point. Once the class is closed, everything is all ready to go. And if we call our repeater class again, then we'll actually get the same input as we got before, which is we'll see before, after, and then the expected output. But annotations on their own isn't what we were trying to understand here. That's just a piece of the puzzle. The thing that we're really trying to understand is type checking. So let's think about how we could use annotations to do type checking. A very naive way to do it would be to use these hooks that we've made and actually just manually check the types. So we can always just raise an exception if a particular argument isn't what we expect it to be. And we can do the same for the return value. And this isn't crazy, but I don't think it's particularly maintainable. There's a couple of things that are quite ugly here. One is that we're referring to arguments by their position. What if we decide to move them around? That's terrible to maintain. Same with keyword arguments, where we're basically just referencing into a hash here, which is pretty ugly. It's also just verbose. I mentioned Java before. We're not writing Java, and we don't want to be. So let's see how we can start to use Ruby to do what it does best, which is compact things down, play some code golf, and see what we end up with. So what we want is something that looks more like this. And I've used different terms to Sorbet just to help keep things a little bit separate. So the module that we're going to build is called types rather than T::sig. And instead of sig, I use type def. which is mostly because I was originally a C and C++ programmer. So that term is quite dear to me. And the API that we're going to end up with is this typedef do, and that will let us call params to specify the types for all of our parameters, and it will let us call returns to specify the return type. So we can have a look at the scaffold for this. Instead of before and after as hooks, we now have this hook called typedef. And how this works is a little bit interesting, because the problem we have with this is, we've got a method we want to call called typedef, and we want to pass in a block to it. But then inside that block, we want to call params and returns. Ruby actually makes this really easy, because you can implicitly pass in a block and then call yield to call that block within the current scope. I'm not even going to explain what I just said, because that's a lot to unpack. Just trust me, it works. And what it means is that we're then able to call these params and returns methods. And these are a bit like the hooks we had before. They really just store the arguments passed into them so that we can use them later. And now, if we look at the bottom of this scaffold for the types module, we see our friend method added and 3 dots, which tell us that something big is coming. But it's actually not that bad. It's actually really similar to the structure we had before. And this is thanks to metaprogramming being a first-class citizen in Ruby. So we've got the same logic to avoid the infinite loop. We've got some bookkeeping to maintain the current context. And then the last few lines actually look really similar too. We store the original method in a reference, and then we call define method to replace it with something new. Where things get interesting is we've got this little helpers module that we have, where we've got a function call checked, and we pass in all of the information that we stored about the types and the method we want to call, and we let that do all the heavy lifting. So let's look at what this helpers module looks like. Really, the key things that this module or this helper method is doing is it checks positional arguments, then it checks keyword arguments. And I'm going to talk a bit more about the differences there later. And then it calls the method and checks the return type. Now, we're doing things pretty naively with this implementation, and there are definitely ways to do it better. But for the most part, this works for basic Ruby methods. The key thing that we're going to run into is some of the nuances of positional arguments in Ruby. And hopefully this will be a really useful takeaway for everyone here tonight. But the important thing for now is we can rewrite the repeater module using this, and it will work. I tested it. And we can write a little wrapper around this and take one of the examples we had before. And now we can pass in an argument with a type that isn't expected. So in this case, we're replacing the count, which should be an integer or numeric, with a string. And our type checker successfully identifies that that is not numeric, which is what we expected. And it can even tell us which argument violated this constraint. So arguments are indexed from position 0. So pos1 is the second argument in the list. So as I said, there are some shortcomings in this types module. And specifically, it doesn't support all parameter types in Ruby because there are quite a few. And by the end of this talk, we're going to support 6 of them. There's actually more than that, but 6 will suffice for tonight. Now, the reason I've left the 3 question marks here is as kind of like a hint for what we don't support yet. So if you look at our syntax that we've settled upon, when we call params, we're matching the positional parameters 1 for 1. So str is a string, count is numeric, separator is a keyword argument, so we'll worry about that later. But what about variable argument lists? So what if you want to be able to support, the string and then the count and then a variable number of other positional arguments? Well, we can't do that here. It's just not going to work. We have to know exactly how many there are to begin with. Now, if you do end up following this by looking at the repo on GitHub, part 2, which I've highlighted in the corner here, is where the second workbook there begins. So that's where we start to dig into things a little bit deeper. And it includes some examples of how we can actually look at methods in Ruby and understand parameter types a bit better. And it's funny, like all the names of these things are actually just surprisingly obvious. So if you call method to get a reference to the current method, you can then call parameters on that to find out about the parameters. And you can use all of the usual Ruby machinery there. So parameters gives you an array, you can call .each, and you can just look at what that spits out. So what we've done with this first example, test 1, is we've actually used 6 different parameter types here. A is a required positional, B is an optional positional, C is a variable argument list, D is a required keyword, E is an optional keyword, and then F are all the other keywords. So you can start to see it gets pretty intense once you start digging into how all this works. And that's why running these experiments is really helpful. So if we ran the previous example, this is the output we would get. And these are the short symbol names that have been given to those different parameter types: rec, opt, rest, keyrec, key, and keyrest. And some of the weird naming for this comes from the fact that keyword arguments were a later addition to the language, and the naming had to be internally consistent with older versions of Ruby. The other thing that's really important to internalize when you're writing a type checker like this is how arguments are bound or distributed across the parameters. And it's worth going into a little bit of a aside here. And I apologize if this is a bit comp sci-ish, but the terms arguments and parameters are often used interchangeably. But when you're writing a type checker, it actually starts to be important to know what the difference is. Now, the traditional take on it is when you actually declare a method and you give all of your parameters names in the method signature, those are what's called parameters. So they're essentially the constraints that you're applying to a bit of code. The actual values that you pass in, those are the arguments. So the arguments are the input, whereas the parameters are the names that you give to those inputs. It's 2 different ways of thinking about it. So when we ask Ruby through metaprogramming to tell us about the parameters, so we can see it's not telling us anything about the values we've passed in, it's telling us about the names that we give those values once they're given to us. Now, to actually get the values or do anything with them, we can use this binding.local variable get trick here. What this does is binding is basically a metaprogramming reference to the current scope. And you can do things like read local variables as long as you know what the name of those variables is. And we happen to know that because that's just the name from our parameter list. So we can run the same example again, but this time using test2. And we can see a similar output, but this time shows us on the left what the name of the parameter is. And on the right, it shows us the value that has been bound to it. And I believe there was an error here, which I'll correct before I distribute any of this later. Yeah, these two examples or outputs were interchanged. But don't need to go into too much detail. Key thing here is you can run these experiments to see how Ruby handles things like variable argument lists. And the reason this is wrong is if you look at test 2 here, we're passing in 1, 3, 4. But what should really be happening here is the binding should be A is 1, B is 3, because it's a positional argument, and then C should only be 4, not 3 and 4, which is what we actually see here. So I'll fix that up before this gets passed around. So one of the key issues we have is positional parameters and how we're handling them. And our type checker currently assumes that the number of positional parameters is fixed and known ahead of time, which is not always going to be true. So to actually test this out, let's modify our repeater, make it a bit more powerful. So now the repeater takes a string, takes a count, which is going to be 1 by default, and then it takes a list of 0 or more additional multiples of that. And then it will just multiply all those numbers together and then repeat the string that many times. You would never want this in real life, but it's useful for this example. And what this means is we can call the repeater now, pass in our string and say pass in 3 and 2, becomes 6, and it will repeat the string ABC 6 times. The reason we do it like this is because we wanted to see what happens when we use all 3 kinds of positional arguments. So it's purely illustrative. The other thing that changes here is instead of specifying the parameters positionally, we actually give them names, because there's no way to reference the variable argument list by name, so by position, because it has 0 or more positions. So we have to use its name. This is actually making us more like Sorbet at this point. So maybe when you're looking at a library like Sorbet and thinking, oh, I'll try to do what it's doing, really try to do what it's doing rather than doing it the easy way. Now, unfortunately, handling this becomes a bit more involved as well. So our method added still has all of the usual boilerplate, but now our define method bit at the end has grown a bit bigger. We have 3 helper functions now. One's for checking positional arguments, another for keyword arguments, and then another for checking the return value. And we're going to look at how to implement checking positional parameters here. And then if you're really interested in keyword arguments, you can either try to do this yourself, which is an interesting little challenge, or if you just want to skip to the end, you can have a look at the Git repo. And there's one that I coded up on the tram ride here today. So it doesn't take too long. And the one we get for free is checking the return value. That's just easy. So what is this mess? This is what we have to do to check positional arguments. Basically, we pass in the list of arguments that we've been given and the types that we expect from them. And then also everything that we know about the parameters for the method. And we have to tie all this together in some way that makes sense. Now, the way we do this is a little tricky. So args is just going to be an array. It's just all of the arguments that we've been given. So we iterate over that using each with index. And then our parameters, the ones that we got from Ruby using metaprogramming, they're all going to be positionally aligned as well. So that's why we use the index, because if we're evaluating the first argument, we want to compare that to the first parameter. And then if it's the second argument, we want to compare that to the second parameter. Except for the one little tricky case of that variable argument list. And I'll hopefully be able to explain the trick here for handling that, because it is a little bit subtle. But first, for each parameter, we check that it's one of the types that we support, so rec, opt, or rest. And if it is, we go and save the type of argument that we're expecting. And say that's a string, we're going to store argtype equals string. And then we just do a little bit of a type check there, and at the very end there to determine whether or not the argument is what we expect. Now, if you imagine that we've got 3 arguments for our repeater, and just to remind you what those are, the 3 arguments would be string, count, and then we'll just say 1 argument for multiples. So we can imagine we would iterate over the argument list and we would get 3 elements from that argument list. First one's a string, the second one is numeric, and then the third one will also be numeric. And each time, the first one we'll see is required, the second one we'll see is optional, and then we'll see that the third one is a rest argument. Now that's fine for all of those 3, because the references that we find in params will all make sense. But what happens if we add a 4th? So if we add a 4th argument to that list, then we've actually run out of params to consume, because we've only got 3, string, count, and multiples. So what we actually do is we save argtype up here, or declare it, and just make it nil to begin with. And then we only actually update argtype if we found a matching parameter for it. What this means is that when we get that 4th argument and we don't have a name for it, we just say, well, that's fine. It has to be a rest argument. So we'll just keep on using the previous argtype and checking types using that. And that's what allows us to work with all 3 positional argument types. And so we can exercise that here and see what happens when we pass in A as the 4th argument. And the type checker correctly tells us invalid arg at position 3, expected numeric. So those were the main concepts that I wanted to touch upon in this talk. But I did want to point out that type checking in Ruby is actually a really hard problem, in part because of design choices in the language. So much so that while testing some of my code, I thought to myself, like, surely Sorbet has figured out a way to do this, because I got stuck on a particular problem where it's actually impossible to check the types for default arguments. And the reason for this is because default arguments are evaluated at the time that a method is called. So what I've done here is I've written a little script just to show how you can abuse this functionality of the language to break Sorbet. Because if I can break Sorbet, I don't feel too bad about my code not working. So all we're really doing with this one is we've got a little main method there, and it takes a argument with a default value of time.now. And the reason I chose time.now is because it's very easy to illustrate with this script that every time we call main with no arguments, time.now is getting evaluated again. And you can see on the right-hand side here, we're calling it once per second. So each time we call main, we see 57, 58, 59. And each time, just to be sure, we're asking the question, is this a string? So our method knows that it's not a string, but Sorbet doesn't. And we can kind of understand why that is, just going back to our code here, where we call our type check helpers, and then we actually call the method. Well, the problem here is when we call the method, that's when the default value is evaluated. So these first two lines here have no access to that. And if we check the type after the fact, then it's already too late because it's gone. There's nothing for us to check anymore. So it ends up creating this hole in the type system. And I guess a key takeaway from that is you don't really want to be working with the assumption that your type checker or your type system is perfect. Always look for the holes. Other languages that have adopted types have similar problems. So JavaScript to TypeScript, for example, there are many holes in the type system there, and it's important to understand them because if you're adopting something like TypeScript to avoid bugs, then you should at least be looking for the kinds of code that the type checker can't find bugs in. But there are also some positive takeaways from this. I think metaprogramming is a really fun way to enhance a language. So we've seen that you could actually invent your own annotations here to do all sorts of interesting things, not just type checking, but you could use it for performance monitoring or metrics, or even for doing things like tagging methods for test suites and choosing which ones you want coverage for. It's also a really fun way to get a deeper understanding of the language. Before this talk, I wouldn't have been able to tell you what those 6 parameter types for Ruby are. And I wouldn't be able to tell you that there's one that we're actually quietly ignoring here, which is blocks. There's also the fact that Ruby's parameter types are complicated, and that is something that we actually get to be blissfully unaware of most of the time because it does just work. And I think that's one of the nice things about Ruby as a language is you only have to dive as deep as you want to. And it's usually a pretty fascinating journey going down these rabbit holes. So leave time for questions. Thank you. That's it. Yeah, that's it. Yes.
Is it actually impossible to evaluate the defaults on the parameter, or is it just something that's Sorbet not implemented?
My understanding is that the only way to do it would be to modify MRI in C and implement type checking at that level. So you'd effectively be introducing a new metaprogramming concept into the interpreter, where the ideal scenario is it tells you what the arguments are as they're being evaluated, and it gives you a chance to hook in and check them. But it would be such a deviation from Ruby's current metaprogramming system that it would I expect it would break a lot of things. If you come up with a way of doing it, though, let me know. I'd really like to know. Sorry?
I'm pretty intrigued to play with it. It's a really interesting problem.
Yeah. I was actually really surprised looking at Sorbet's source code that I couldn't find anything, any obvious attempt on their part to work around the problem. I think they just accept that it is what it is. All right, can probably wrap it up there. Thank you, everyone, and hope that was fun.